All right, today we're going to learn about in 12.2 arithmetic sequences, and we're going to talk about the linear part that goes with this. When we talk about these linear or discrete, when we graph them, sequences, we're looking for a sequence with a common difference. You're going to treat that common difference, the d, as the slope. So if we look at our equation here, we have a sub n equals a sub 1, the first term, plus n, the total number of terms, minus 1, times d, or that common difference. So a sub 1 is always the first term of the sequence, and d is always that common difference, which you can think of as your slope. And we talked about this a little bit yesterday. Okay, we're always going to simplify this down. So once we substitute our numbers in, we're going to simplify it down to a sub n equals d times n, where n is your variable, plus b. Think of b as a sub 0, or the 0 term. It's kind of like your y-intercept. This is very similar to y equals mx plus b. So when we look at this first part, it says write a rule for the nth term. Okay, so it says write a rule for the nth term of the sequence, then find a sub 15, or the 15th term. So as we're looking through this, we look and say, all right, to go from 60 to 52, you're subtracting 8. 52 to 44, you're subtracting 8. So each time here, we're subtracting 8. That negative 8 is your d, or your common difference. Okay, your a sub 1 is your first term, which in this case is 60. Okay, so we can substitute in what we know. So we know a sub n equals your first term. So if I pull up that equation, it's your first term, 60, plus n minus 1 times your d, or your common difference, that negative 8. Okay, then we're going to simplify this down to give us 60, and then we're going to distribute that negative 8 in, so it's going to be minus 8n plus 8, or we can say a sub n equals negative 8n plus 68, and I'm going to make that look a little bit better here. Negative 8n plus 68. Okay, and that's your rule that we're going to use. Now, the second part of this asks us to find a sub 15. So all you're going to do is you're going to say a sub 15 equals negative 8 times 15 plus 68. Or, when you simplify that out, a sub 15 is going to equal negative 52. And that is how you would use this rule. Okay, if we look at this example on the left, you are adding 3 every time, right? So we know our common difference has to be equal to 3. Your first term is 5, so if we substitute this in to find your rule, you get a sub n equals 5 plus n minus 1 times your common difference, which is 3. Okay, if we distribute this in, you end up with 5 plus 3n minus 3, or you get the rule a sub n equals 3n plus 2. Okay, now when we have a problem like this next one, it says one term in arithmetic sequence, which tells us we're going to be using this linear rule. We know that a sub 19 is equal to 48. Okay, we know the common difference is 3. So what we need to do first is we need to substitute in to find your initial term in order for us to write a rule. So when we have our equation, or our base one, a sub n equals a1 plus n minus 1 times our common difference, okay, we know n is 19, We know when n is 19, the whole thing equals 48, and you know your common difference is 3, so we can substitute in what we know. So we know a sub n is 48. We don't know the first term, that's what we're looking for. But when this equals 48, that is your 19th term minus 1 times your common difference. So when we simplify this out, you have 48 equals a sub 1 plus 19 minus 1 is 18. 18 times 3 is 54. And then solving it out for a sub 1, you subtract 54 on both sides to get negative 6. So then you can use your rule and say a sub n equals negative 6 plus n minus 1 times 3. Simplifying this out, you get a sub n equals negative 6 plus 3n minus 3, or you know that a sub n equals 3n minus 9. Okay, and that is your rule that's going to go with this. When we go to write a rule if you're given two terms. Now notice how you're given two terms. You don't know a common difference. You don't know the first term, so you got to solve for both of those things. Okay, when we are writing our term or trying to find that common difference, remember we said treat that common difference as if it's your slope. So if we're going to do that, our common difference d is going to be equal to, think of 97 and 21 as your y. So we can say 97 minus 21 over, and then think of your term numbers as your x's. So a sub 27 means we got a 27 minus a sub 8 means you got your 8th term. And now we can figure out what that slope is or that common difference. So you get 76 over 19, which will in fact simplify down to giving us 4. Okay, and that 4 is big because that's going to help us find your initial term to help us write our rule. Now when we go to find that initial term, or a sub 1, you just need to pick one of your terms. A sub 8 equals 21, or you could use a sub 27 equals 97. Preferably, I like the smaller one because then it's easier to just kind of calculate my numbers. So I'm going to say that 21, just like we did before, is equal to a sub 1 times, when we do that, that's our 8th term minus 1 times your common difference of 4. Oh, and there's a plus sign in there. So that gives us 21 equals a sub 1 plus 8 minus 1 is 7. 7 times 4 is 28. So we can find that negative 7 is actually your first term. And now that you know your information, you can go ahead and write your formula. Okay, so we can say a sub n equals your first term plus n minus 1 times your common difference of 4. Or a sub n equals negative 7 plus 4n minus 4, which, simplifying it down, gives us the rule 4n minus 11. Okay, and that would be your rule for this problem. Okay, with this is all the further we're going to go. We'll finish our notes tomorrow on the arithmetic series where we're trying to find the sum of the first n terms. We'll do that part tomorrow. Otherwise, have a good day. Work through the second part of your homework. It is actually 2 sheets, but just do the stuff you can using our rule, and then we will finish this up tomorrow and Friday.